So to get things started, the very first question we have to ask is, well, what exactly is this thing called an IP address? Now, these days, most people have heard of the term IP address. I mean, even my mom, who doesn't know anything about computer networking, she knows that her computer has to have an IP address to talk on the internet. We know that. We know the term. But what is it really? Well, when we want to break it down to the technical aspect, it's a 32-bit address that is used to uniquely identify a computer on a network. Now, the first thing I want to point out there is that I said it's a 32-bit address. Now, this is getting just a little bit ahead of myself because I mentioned that we are going to have the math lesson where we talk about binary numbers. Well, when we deal with binary numbers, which is ones and zeros, they are referred to as bits when we talk about computing. And so an IP address, although we typically see it as four numbers separated by dots, it's actually 32 ones and zeros. But again, we'll get into that a little bit later on in this lesson. Now, if we take this 32-bit number that is used to uniquely identify a computer on a network, okay, I suppose I should talk about that it's uniquely identifying a computer. It's an address that every computer within a network must have and must be unique from every other computer, or really instead of just computers, we should say hosts, because computers have IP addresses, and then other networking devices like a router would also have an IP address. So they all must be unique, but here's the deal. You take this number and you actually divide it into two different components. One portion of the IP address is what's known as the network ID, and that identifies what network that particular computer or that particular host is on. And then we have the host ID, and this is the portion of the IP address that really makes that individual computer or host unique within that network. So what that means is we can have a bunch of computers that will all have the same network ID. Okay, so a certain piece of the IP address will be the same as all other computers on that same network. But then the other part of the IP address, the host ID portion, that's the part that truly makes it unique within that network. Most of us have just simply learned that every computer must have its own unique IP address. We've learned that every single computer just has to have its own separate IP address from any other computer in the world. And this is only partially true. And as we go through the rest of this lesson, hopefully by the end, you will see that technically you can have more than one computer in the world with the same IP address. Okay, but again, I don't want to get too far ahead. Okay, this is just talking about the basics of, well, what is an IP address? Now let's see if we can break down and get into this whole network ID and host ID thing. All right, so here's an example. Okay, we have an IP address which would be simply listed as 192.168.10.1. Okay, if you take that IP address, here's what we know. We know that the leftmost portion of this IP address, okay, so the left half, we'll say, is the network ID. We also know that the right half, okay, so the right side of this IP address, is the host ID. So that's the unique identifier within the network. But here's what we don't know. What we don't know is, where do we draw the line? Okay, because I started to say the leftmost portion. Well, that leads you to believe that it's just maybe the 192, or maybe even just the 1 in 192. But then I corrected myself and I said, well, no, it's the left half. Well, by saying half, that's not necessarily correct, because that makes you think there's a line right down the middle, and then 192, 168 would be the network ID. Neither of those statements were truly accurate. It's not the leftmost portion or the left half, it's just the left side. And the host ID would be the right side. But we don't know where the line is dividing that left side and the right side. What we need to do is we need to add something called a subnet mask. Now, the subnet mask, right now, for simplicity, before we get into the binary lesson, I will tell you, is made up of the number 255 and the number 0. And there will always be 255s to the left and there will always be zeros to the right. And the reason why is because that's what distinguishes where we draw the line between the network ID and the host ID. So in this example here, if we have a subnet mask of 255.255.255.0, what that means is the first three numbers, 192.168.10, because the first three numbers in the subnet mask are 255, well, they're the network ID. Okay, so we know that that left side wasn't the leftmost portion, and it wasn't the left half. It was actually the left three numbers, 192, 168, 10. That's the network ID. That is the name of the network that we're on. And anywhere you see a 0 in the subnet mask on the right side, well, that represents the host ID. So in this case, it's just that last number, just the 1, all by itself. That's the host ID. So every single computer on the 192.168.10 network would have to have a unique number from any other computer on that same network with that just that last number. Okay, so one computer might have a 1, might have a 2, one might have a 3, and so on and so forth. But it doesn't have to be that way. We could have a subnet mask of 255.255.0.0, and in that instance, we're now on the 192.168 network, and 10.1 represents the host ID of this computer on that network. And another computer might have 10.2, and another might have 10.3, and another might have 11.1, and another might have 12.1. Okay, so as long as there's a unique 2-digit number, and again, I want to be careful with the digits and things like that, but as long as the entire host ID is unique, we're okay. It doesn't mean that both of those columns have to be unique. Okay, we can have 10.1 and 11.1. They both had .1 at the end, but that's okay because the host ID was the last two numbers. Or they could have 10.1 and 10.2, where the 10 stayed the same, but the 1 and the 2 changed in the last number. Now, believe it or not, we can even have a subnet mask of 255.0.0.0. And that would mean that we're on the 192 network. Okay, so the network's just called 192. And the hosts would then be unique based upon the last three numbers in the IP address. And by the way, besides just saying the last three numbers in the IP address, a more official term would be the last three octets in the IP address. And the reason we call them octets is, remember, an IP address is a 32-bit number. Okay, if we break it down to binary, it's 32 bits. But that's then broken down into these four numbers. Each of the four numbers is an 8-bit binary number. And that 8 bits can also be represented by the term octet. Oct for 8. So just in case you have ever heard that term before, or if you hear me use that term, an octet is just one of the numbers in an IP address.